Continue. Product and quotient rule. Let's get started. You know it, I know it, we all know it. Let's read them out. The derivative of f times g, where f and g are both functions, and I'm taking the derivative of both of them with respect to their variable, is f prime g plus fg prime. Extended to the case of three functions, it's f prime gh plus fg prime h plus fg h prime. And that's the derivative of a product. That's the product rule. And here's the derivative of the quotient. F prime g, take fg prime all over g squared. Okay, let's apply them. "11 problems to do. We'll begin. F of t is this factor here, is this function here, quadratic function here, multiplied by this cubic function here. If I were to multiply them out, that would be extensive, and then I would be taking the derivative of a big polynomial. But let's use the product rule. Differentiate the first function and leave the second one alone. Plus differentiate the second function and leave the first one alone. Then think about whether it's prudent or wise or good to expand it out. So I'll just do it. So first I'll multiply 8t by everything here. I'm going to have 8t to the 4, take 64t cubed plus 96t. Then multiply everything by -1. So, wait, how can we be organized about this? Okay, I'm going to do, when I multiply them by -1, I'll do it underneath. And yes, so I'll get -t cubed plus 8t squared. Okay, this is good. I'm thinking about the structure. Plus 8t squared minus 12. Then over here, we get, upon doing 4t squared by that and that, we get 12t to the 4. Then minus 64t cubed. Then minus 3t cubed plus 16t squared. And now we add everything up. 20t to the 4. So that's minus 128 minus 129, so minus 132 t cubed. 24t squared, 96t minus 12. And that's my final answer to that one. We'll see if it's right. that's correct, and that's good. Okay, second one. dy by dx. Okay, differentiating this. This here is x to the 3 over 2. So when we differentiate that, we get 3 over 2 x to the half. And then leave the second function alone. Plus, leave the first function alone and differentiate the second function, in which case we get minus 3x to the minus 4. And here, this is 2x to the 1/3, or rather negative 2x to the 1/3, so it becomes negative 2/3 x to the negative 2/3, like that. We could multiply everything out here. So that's a half there, that's a negative 3 there, so it's going to be negative 2.5, which is negative 5 over 2. So 3 over 2x to the negative 5 over 2. And that there is going to be minus 3 for the coefficient. That's a half power. That's to the power of 1/3. So it's going to be half plus a sixth. A half, yes, is that right? Yes, that is right. A half plus a sixth, which is 2/3. So x to the 2/3 rather. Or so I believe. Then FOIL. And here, okay, that's first, outside, and then minus 2/3 x to the minus 2/3. And inside, so we're going to have, that's the square root, so 3 over 2 plus minus 4. So that's minus 4 plus 1.5, which is minus 2.5, which is minus 5 over 2. So minus 5 over 2. So minus 3x to the minus 5 over 2. That's the inside. And now the last. So that's x to the 3 over 2. And we're multiplying by that. So what's 3 over 2? Take 2 over 3. 3 over 2 take 2 over 3. Well, that would be 9 over 6 take 4 over 6, wouldn't it? Which is 5 over 6, I think. So minus 2/3 x to the minus 5 over 6. And really, there's not a whole lot that we can simplify here. We could, yes, in fact, actually just simply that term there and that term there. That's all I can really see to simplify. I'm curious to see if he went through that process as well and quote unquote simplified it. And he did. All right. Okay, but what we need to do is we need to check and make sure that we did it. We differentiated it okay, because I don't think most people would expand this. No, we need to make sure that the end is actually correct. So is that correct in the correct spot? Yes, it is. And this 3 over 2 and this minus 3 well, they would combine together to give minus 3 over 2. So I see that that's correct. If I were to write them out and actually combine them together. And then that's correct there. And the last one really to sort out is this one. So unsurprisingly, that was not correct. So 3 over 2 plus that's 3 over 2. And when you add that, you will get 4 over 2, surely. Am I even thinking straight about this? I hope so. Oh no, beg your pardon. That's a third. And a third and a half is actually 5 over 6. Of course it is. It's always the arithmetic. And when you that would be positive as well. And then they would combine together. And then we would get negative 3 minus 2 over 3, which is minus 11 over 3. And that's how and then I understand it. Yes, I see that now. Okay, great. All right, so I feel that was kind of artificially difficult, to be honest. Not actually. No, I mean, I don't want to complain. I want to actually get better. And right, h prime of z, product rule once again. So differentiate the first function. Six z plus 2. Leave the second function alone and put it in order. And differentiate the second function and leave the first one alone, putting them in order. Negative 3z squared plus 16z plus 5. Then let us use our polynomial multiplication skills and actually work this out. It's really not so bad. It's just 6 products and then 9 products and then add them together and just be careful. That's all you have to remember, really. So everything there by times by 6z. So we get negative 6z to the 4 plus 48z cubed plus 30z squared. Then multiply everything by 2, so minus 2z cubed plus 16z squared plus 10z. Then over here, first I'm going to be organized and logical. So minus 9z to the 4. Then 48 minus 6 is 42. So 42z cubed. Then 15 plus 32 is 47. 47 minus 3 is 44. Then 10 plus 16 is 26. Then 5. And now adding as we would with column addition. Minus 15z to the 4. 48 minus 2 plus 42 makes 88. 30, 16, and 44 together make 90. 36z, 5. And that's my answer. Okay, so they did it in reverse order, and I understand why they did that, and that's correct, and that's good. Next, the product, the quotient rule. And how does that go? That goes like this. The derivative of f over g is f prime g take f g prime all over g squared. So this will be f prime times g, so minus f g prime. What's the derivative of that? Well, that would just be -1 all over the square of g. Now that we have it in template form, then we actually do it. So on top, that will be minus 12x squared plus 24x plus 6x squared. Minus 12x squared plus 6x squared, so that's minus 6x squared. Plus 24x. Squared minus 4x plus 4. If we felt inclined to expand it entirely. However, no, I feel that's fine. Let's see if that's right. Okay, they didn't feel the need to expand it there for some reason. When do you actually do it then? Like, what's the actual criteria? I mean, it's correct what I wrote, but still. What are the criteria? Not what is the criteria. R prime of W. F prime G minus FG prime all over G squared. So that prime minus F prime G minus FG prime. So we leave the top alone and differentiate the bottom. And then square the bottom. So following his example from above, I'll just clean up the numerator and leave the denominator alone. So what do we get up there? We get eight w to the 5 plus 4w cubed plus 6w squared plus 3 minus 4w to the 5 minus 12w squared. And then we clean everything up. So minus 4w to the 5 on top. No, rather, just plus. Then 4w cubed. Then okay, so f prime g minus fg prime all over g squared. So f prime is minus fg prime that's going to be minus 8x plus 7. All over this squared. Now, when we do this, what do we get? Well, you get a big mess. I'm joking. I mean, really, it is going to be a mess, isn't it? So let's clean it up. Let's actually do it. Right? So, whoops. Oh, who knows what's happened now that I've pressed undo a few times. Okay. So FOIL on the first. So minus 2x to the 3 over 2. Plus 7 over 2x to the half. Minus 8x squared. Plus 14x. Then that's x to the half. So that'll be minus 8x to the 3 over 2. Outside minus inside minus 16x squared. Last. Now, common terms, if any. And what's the highest power here? That one. So minus 24x squared. That's going to be first. Then 3 over 2. Then 1. Then a half. Okay? So plus 6. Then and last, so that's adding 3.5 to negative 7. So we get negative 3.5 or negative 7 over 2. So there. That's what I think the answer to that is. And could you factor something out? Well, yes. I think you could factor out the square root of x. Maybe you could do something else here. But he didn't feel the need to expand it at all. What's the science? When do you expand and when do you not? It's up to him. So, if in problem 7, now we must think a little bit, little less mechanical. If f of 2 is negative 8 and f prime of 2 is 3 and g of 2 is 17 and f prime of 2 is negative 4, determine the value of f g prime of 2. So right. And that, which is 3 times 17 plus negative 8 times negative 4. And so that would be 51 and 32, which is 83. And that's right. Problem 8. If f of x is x cubed gx, I'm sorry, what? Just roll with it. Just roll with it. We're going to turn that fact into this. Okay, so quotient rule. F prime g minus fg prime all over g squared. Thus, the very thing that we don't know, times by g of -7, which is 2, minus f of -7, which we don't know, times g prime of -7, which is -9, all over g of -7 squared, which is 4. And that, well, that is, let's think, we know f of x over g of x, and therefore the prime of that is the prime of that, which is 3x squared. So 12x squared but wait a minute. We know that in this case, x is supposed to be -7, isn't it? And -7 squared is 49, and 49 times 12 is 490 plus 98, which is 588. Okay. Hope I'm not missing a fact here, or missing a connection or something. Oh, yes, we can do it, actually. We also know that that's 2, and f prime of -7, which is something that we don't know right now. But you divide that, and you get x cubed, which in this case we actually do know. Two times the cube of -7, and the cube of -7 is -343, so it's -686. So at least try to make the notes somewhat linear. So 588 is 2 times f prime of -7 plus 9 times -686. This is what I think anyway. Could be completely and utterly wrong. So I think it's 3381. This could be colossally wrong. It's a nice integer, but it just seems way too big for everything that's involved. There's only one way to find out. To check. Oh my goodness me, I'm right. Wow. That's a great feeling. Okay, now find the equation of the tangent line to f of x at x equals 9. So let's compute the derivative. First, though, the point in question. (12 times the square root of 9), all times 4, take 9 squared. So 1 plus 12 times 3, which is 37. 4 take 81 is minus 77. A firework? No. That is right, isn't it? 4 take 81 is minus 77? Yes. Okay, now try to multiply these two numbers. There. So 9 comma negative 2821 whoops, a prime of x. Let's get the derivative. Differentiate the first function, leave the second one alone. So we get, so that's 12x to the half, so 6x to the minus half. Leaving that alone. Plus derivative of the second one, leaving the first one alone. Then compute f prime of 9 to find the slope at that point on the curve. And so what is 9 to the negative half? Well, 9 to the half is 3, and 9 to the negative half is a third. And 6 times a third is 2. Four take 9 squared, well, that would be minus 77. And then plus negative 18. 1 plus 12 times 3, so 37. And then we compute this. Better not risk it. Minus 820. M of tangent, or gradient of tangent, if you like. Y minus y1 equals m times x minus x1. And we apply it. So we say y plus 2821 equals minus 820 open brackets, x minus simply 9. And put it all onto one side. So y is equal to negative 820x. So then do 820 times it by 9 and take away 2,821 and we get 4,559. And let's see if that's right. Oh, darn. Let me guess, this number up there isn't right. Oh, of course it's not. Oh, goodness me. All right. 37 times 77, try it again. 21, 28, 28, 49. 28, 49 is the right answer. I really need to just do separate sessions just to make sure that my accuracy of arithmetic is up to scratch. I don't know what it is, why it suffers so much during these lessons, during these practice runs. 820 times 9 minus 2, 849, 4531. And we check. And now that's correct, and that's good. Tenth problem. Determine where f of x, which is a rational function, is increasing or increasing and decreasing. So, of course, we must take the derivative. We must find the derivative. Oh, goodness me, I feel that this is going to be horrendous. Proceed. F prime, so minus 2x. G minus f G prime like that. And now we need to determine where this is greater than 0 and where it's less than 0. So That's actually... How is that doable? Notice the denominator is squared, and therefore it is always positive. So we need only consider when the numerator is positive or negative. And we'll do that. We're just going to apply the QF. Literally nothing fancy, just straight up quadratic formula. Fraction button, minus b, so minus 2 plus square root of b squared minus 4 times minus 8 times c all over 2 times minus 8. Literally just super mechanical. And this is a parabola that's opening up downwards. So it's only positive between those 2 points. So there. That's according to my calculations. We're about to see if that's any good. Hooray! It's correct. Wonderful. Problem 11. Determine where that function there is increasing or decreasing. So we must take a derivative, v prime of t. Differentiate the first. And leave the second one alone. Plus, differentiate the second. And leave the second one alone. And when I do that, Whoops, indeed. Like that. And what now? What now? Now you solve. Oh, right. Whoops. So rather, v prime of t equals 0 when t is 0, or setting that equal to 0, we get 19 over 10, square root plus or minus the square root of 19 over 10. And what else can be said about it? All right, so visualizing now. It's a cubic that passes through negative square root 19 over 10, 0, and positive root 19 over 10, and it's a negative cubic. And this is the derivative, not the actual function itself, right? And so where is it increasing? It's increasing where the derivative is positive, so that there, and that spot there, and it's decreasing where it's negative. Yes. So we say Vt is increasing for there and there and Vt oh wait. There. Hooray, correct. Wonderful. Right, so I'll be back to do this, but I must rest my hand, my eyes, and brush my teeth. But yes, very likely be back. 3, 2, 1, be well.